Hi everyone, today we are going to discuss lesson 21 of Algebra 1A. The objectives for this lesson is so you will be able to graph a system of equations by graphing each equation using an appropriate method, and you will also be able to identify a solution to a system of equations by finding the point of intersection. Let's go over some key terms. First, we have a system of equations, which is two or more equations that must be true at the same time. The notation for a system uses the open brace. Coincident lines are two or more lines that lie on top of each other in the coordinate plane. So I'll give you an example of that in a bit. Parallel lines are two or more lines or coplanar lines that never intersect. Keep in mind, parallel lines have the same slope. Infinitely many solution is a system of linear equations that has the same line, basically, which are also called coinciding lines, and every point on that line is a solution. Intersect is when two lines or geometric figures cross each other in a coordinate plane. The points where the line cross is or are, depending on the situation, is called the point of intersection. No solution is a system of equations that has no solution if we have parallel lines, basically, and we have an empty set. Solution is the value or values of the variable or variables in an equation that cause the equation to be true. So I'll give you an example of that also. So system of linear equations. Like I mentioned earlier, it is a collection of linear equations involving the same set of variables. Here are some examples. The first one is a system of linear equations, second one also. Notice we're only using x and y, and we're going to only use x and y for the rest of the PowerPoint. So what is a solution exactly? A solution to a system of linear equations is the point where the lines intersect. So here's an example of two lines on a plane. This point right there, really 1, 1, is what we call the solution to the system of equations, because that is where the two lines intersect at. Different possible solutions. So exactly one solution, which we mentioned earlier, was when they only intersect at one point. For example, in this graph right here, it intersects at 2, -2. Second one is called infinitely many solutions. They're coinciding lines. So this occurs when the lines are the same. So I don't know if you can see it, but there's the black line and then there's the purple line. They're the exact same line. They overlap with each other. We have no solution, and this occurs when two lines are different and they are parallel. The black and the purple, no matter which direction you go, you keep going, you will never ever see those two lines cross because they have the same slope. So classifying linear equations. So earlier we used intersecting lines. So keep in mind, intersecting lines have different slope, but they could have the same y-intercept or different. That does not matter. The key point is them having different slopes. Next one, coinciding lines. They have infinitely many solutions, which means they have the same slope and the same y-intercept. Last set is parallel lines. We mentioned earlier that means no solution. So they have to have the same slope, but they must have a different y-intercept. One solution. So again, I'm just repeating a few things so you can see it in different ways. Intersecting lines have one solution. They must have different slopes. Remember, they could have the same or different y-intercept. So the previous slide I showed you in graph form. Now I'm going to show you in equation form so that you can see it. For example, this first one right here, set of linear equations, we have 3x plus 4 and then -2x plus 6. Notice they have different slopes, 3 and -2, and they also have different y-intercepts. The second one They have different slopes, right? 4 and -3, but they have the same y-intercepts, which again is okay for intersecting lines. So the easiest way to see it is if you have these equations in slope-intercept form, and if it isn't, you can always rearrange it so that it is. If you don't want to, you can simplify the equations and then you can tell from that. So infinitely many solutions, again, they're coinciding lines and they have infinitely many solutions. They must have the same slope and same y-intercept. So here's an example. Looking at it, you probably think they don't look the same, different numbers, right? But in reality, they have the same slope and the same y-intercept. Same with this example. Even though it's in standard form, they are the same slope and same y-intercept. You look at it probably thinking, how? Well, if you simplify this one by 2, dividing the whole equation by 2. Remember, you must divide the whole thing. 2 divided by 2 is 1, so we have 1, or just y. 6 divided by 2 is 3, and then 8 divided by 2 is 4. So when you simplify, they are the exact same equations. Same thing with the second one. If you multiply, or better yet divide, let's divide all of this by 3. You should get 2x plus 3y equals to 8. So again, they are the same. Alright, so again, make sure to find out for sure. Make sure that both equations are simplified, because if they're not, you can't tell for sure. Same thing with no solution. So remember, no solution have same slopes and different y-intercept. So here's an example. This one have the same slopes, 3, same slope, but the y-intercepts are different. One is 4, one is 5. Second one, same slope, but different y-intercept. So if you were to divide this whole thing by 3, you would have 2x right here plus 3y, but the y-intercept is going to be 13.333, something like that. And as you can tell, the coefficients, this is how you know if the slope would be different or not. If the coefficients are the same in standard form for the x and the y, that means they will have the same slope. But if they're different, like if this had said 4 and that had said 2, then they would be intersecting lines. Alright, so again, to find if lines are parallel, make sure both equations are simplified. Alright, now here comes the fun part. We actually get to graph linear equations. As you have learned in previous lessons, the best way to graph equations is to put them in slope-intercept form. Just a quick reminder, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. Where slope can be found using rise over 1, the intercept, y-intercept, is the point that crosses the y-axis. If you don't remember how to rearrange the equation so that it is in slope-intercept form, we're really just looking for y, or solving for y. So we're going to get rid of the 2x or negative 2x on the left side by adding it to both sides of the equation. When we do that, we get 2x plus 7, and that now is in slope-intercept form. Alright, so let's go ahead and actually graph. So graph the system below and write its solution. So the red one is already in slope-intercept form, so we are going to graph that first. Y-intercept is -2, that's why we have a point at -2. Slope is 3, which means go up 3, right 1. We draw a line, so we have that. Second one is the blue equation. It is not in slope-intercept form yet, so we are going to make it into slope-intercept form. We're going to add 6x to both sides. So we have 2y equals 6x minus 2. Now we need to get y by itself. Let's divide 2 to every single term. When we do that, we get y equals 3x minus 1. So we're going to go ahead and graph 3x minus 1. The y-intercept is -1, slope is 3. So these lines are really similar. You can graph it, right? And you'll see that they are parallel, which means they have no solution. But if you look at the two equations, slope, same. Both have a slope of 3, but the y-intercept, one has -2, the other one has -1. And that's how you know they are parallel. Alright, let's try another one. Graph the system below and write its solution. So again, the red equation is already in slope-intercept form, so we're going to plot that first, or graph that first. And now we're going to focus on the blue equation. It is not in slope-intercept form yet, so we're going to try and put it in slope-intercept form. Minus x on both sides, we have -2y equals -x minus 5. Divide everything by -2, we are left with y equals x over 2 plus 5 over 2. Remember, these two negatives right here can turn into a positive. Same thing with these two. Alright, now we get to plot the blue line. And the solution, remember, is where the two lines intersect. It intersects at that point right there, and that point is -1, 2. Alright, here's another example. Graph the system below and write its solution. Once again, the red equation is already in slope-intercept form. We are going to graph it. The blue one is not yet, so we are going to subtract x on both sides. We have -2y equals -x plus 1. Divide both sides by -2. We get y equals x over 2 minus 1 over 2. Graph that. Point of intersection, it is 1, 0. So that is the solution. So using a graph to write equations. So now we have a graph. We want to write the two equations. And you guys should have already learned how to do that. Right? You always want to find the y-intercept and the slope. So we're going to focus on the blue line first. The blue line has a y-intercept of -1, right there. To find the slope, we want to choose another point. So I'll choose that point right there to find the slope. We are going down 2, which makes it negative, over, on the right side, 1, which is -2 over 1. We can simplify -2 over 1 to be just -2. Then we're going to do the same thing to the purple line. We're going to ask ourselves, what is the y-intercept? As you can tell, that is -5. Again, to find the slope, choose another point. We found that point right there. Find the slope, we go up 2, which is positive. Right 1, also positive, giving us a slope of +2. Plug it into the slope-intercept form, and we get 2x minus 5 for the second one. So those two equations are the equations to the two line on our graph. Alright, here's another one. Same thing, we're going to focus on the blue one first. Y-intercept of the blue line is +3. To find the slope, we need to choose a different point. We're going to choose that one right there. To find the slope, we go down 4 to the right 3, which gives us -4/3. Now we have those. Let's write an equation. It is -4/3 x plus 3. Do the same thing for the purple line. Y-intercept is -2. Slope is going to be -1 over 2, which is -1/2, giving us an equation of -1/2 x minus 2. So just to let you guys know, we have the graph right there. The solution would be this point right here, which would be +6, -5, and that's how you identify the solution, just like we did in the previous few slides. Alright, Here's one example. I want you to try this one out on your own. Pause the video and then resume when you are ready. Let's focus on the blue line first. What is the y-intercept? Y-intercept is going to be -3. What is the slope? Choose a point. We're going to choose that one right there. You can choose any point on the coordinate. It's really up to you. I just like choosing that one because it gives me a perfect number, basically. So slope is going to be +2. So the equation is going to be 2x minus 3. Do the same thing for the purple line. We have y-intercept of +3. Slope is going to be -1 because we're going down 1, right 1. So we have the equation -x plus 3. And those are the two equations. And the solution to this system of linear equations is going to be this point right over here. And that is 2, 1. And that is all that we have for today. If you have any questions on anything we learned in this lesson, feel free to reach out to me.